So in his first experiment in this paper, basically he gave the birds 15 minutes of search time, so to look around, check out the environment, check out where all the cache locations are, or where the birds could cache seeds, right? And then he gave them sunflower seeds. Chickadees love sunflower seeds. And provided them with 15 minutes to kind of store all those seeds in those different locations. And they do this kind of readily. It's something they like to do. Chickadees want to be catching food. All right, so 15 minutes to kind of check out the arena, give them the food, let them store it. And then 24 hours later, so they go back to their home cage for 24 hours. And then the next day, put them back in the arena and give them 15 minutes to retrieve their caches. So during this storage time, David would have also paid attention to where the chickadees stored everything. They might not put, food locations in all the caches. Now, the important part of this search is that there's no food actually present during the search. So David took all the seeds out of the caches. Any idea why that might be actually important to remove the food during search?
Like if they find one and then go off and wait for the other?
Not quite.
Well, like they're small birds, so they probably only need to eat a few seeds each day. So they eat like not a handful, but they eat their handful and then leave the rest.
That is true. Not quite though, not quite what I'm looking for. Yeah.
To remove the variable of them smelling it.
Bingo. Right. You want to make sure you're measuring memory. And if you have the food items there, they could smell them. Birds can smell. They might see them, right? So you have to remove the food. But then you can see what they do, right? They store the food, they think it's somewhere. What do? All right, and of course this is 1984. This is the time where you create your figures not the same way we do now, so this is a bit blurry. But what David did was he paid attention to how much time each chickadee spent at each cache site and how many visits, so the number of visits. And he also did this pre-storage, right? So that's in that first phase, right? And then compared it to when they should be searching for their food, when they're looking for it. And you can see pretty clearly that the chickadees remember where they hoarded their seeds, even though the seeds are not there, right? So chickadee thinks, hey, there should be a seed here. And that's both in time spent, and the number of visits. So this is showing pretty clearly that the chickadees have a memory for these cache sites, right? It's not because they smell the food, it's not because they see the food, they remember where they put it. That's the only explanation here. So as we mentioned, all cues other than memory were removed, and birds successfully located their cache sites. So they use memory. Pretty cool. And this kind of result has been replicated several times. We know chickadees have an excellent memory for their cache locations. And they're actually often used in experiments for spatial memory for that reason. Chickadees even have a larger hippocampus to brain volume ratio than many other animals. Can anyone tell me what the hippocampus is? Yeah.
Memory. It does memory.
Yeah. It's a brain structure important for memory, especially spatial memory. So when you compare a chickadee to another type of bird that doesn't really rely on this kind of system with caching, chickadees are often compared to juncos in this context, because juncos just kind of eat on the ground. They don't cache their food. Chickadees have a larger hippocampus to brain volume ratio than juncos do, because they need that brain region. Okay. Stages of memory. So we know that memory is a process, and it's not necessarily stable. I'll get to what that means. And again, I mentioned this before, but we have different stages of memory. This is another way to think about it: encoding, consolidation / storage. You can think of them as the same for the context of this class, and retrieval. You have to get the information in first. It has to be consolidated, and then later you need to be able to retrieve it. Without any of these steps, memory would kind of break down. All right. Encoding. What is encoding? So that's the conversion of incoming information into signals that will be used for later processing. And not all sensations are encoded. We kind of already talked about this, right? You need to have attention to be able to encode information. Another important aspect is something known as elaboration. Okay? So elaboration is adding meaning, images, or other complex information to sensory input to facilitate memory. This adds processing during encoding, and this leads to a stronger memory. An old example that I was taught to increase memory recall: if you're given like a list of words that you have to memorize, for whatever reason, you try to make a story with those words, and then you can remember it. That's an example of elaboration. Sometimes also adding absurdity to the story can make it easier to remember. So if you have to remember the words, I don't know, school bus, tomato, I don't know, what's another word? Give me a word. School bus, tomato.
Cowboy.
Cowboy. Perfect. Those are the words you have to remember for whatever reason. You imagine a gigantic tomato that is a bus and a cowboy riding inside it. You don't remember the words, right? You're adding more complex information, and it makes a stronger memory. Sometimes even saying something out loud and trying to create an episodic memory, so something that happened, can help this too. So let's say I really have to remember to go grocery shopping later. If I stood up here on the table and went, I have to go grocery shopping, I would remember, because that would be perfect for me, and I wouldn't forget. It's true. It's absurd, but it's more complex information, and it creates a stronger memory. So the next time you really have to remember something, do something really strange, create an episode of it happening, you'll remember. Anyway, that's a bit of a tangent. A cool phenomenon is that information with survival value is also processed with elaboration. So, what is that? So, there was this experiment where they had subjects given a list of words, again, kind of like the cowboy tomato. Subjects were given a list of words and asked to think about them in terms of either survival or non-survival. Tomato might be important for survival, but cowboy, or maybe it would. I don't know. Doesn't matter. Survival or non-survival features. The list of words was the same. Okay. But the key difference here is that they were told to think about it in either an ancestral setting or a modern setting. So survival information in an ancestral setting would be more important than survival in a modern setting. And because it's more important, people remember more in that ancestral setting compared to modern setting. So same list of words. Think about these words in terms of survival. You're either in an ancestral setting or a modern setting. Ancestral setting, you remember those words. Pleasantness is an example of some of those non-survival features. So they looked at kind of control features as well. So pleasantness would be one of those control features. And you don't see a difference in pleasantness in the modern or ancestral setting. So the point there, information with survival value is processed with elaboration. Okay. So moving on to consolidation or storage. That's modifying that information to make it more stable, more usable. But it is possible to disrupt consolidation. You can disrupt consolidation with distracting stimuli, new learning, or neural. That would mean, neural disruption could be actual brain damage, right? Right. So you might be wondering, oh, you're going back and forth with consolidation and storage. You can actually think of them as kind of two stages of consolidation. This is, again, a theory. And some evidence for that is the disruption of protein synthesis, which is important in consolidating memories, can interfere with memory immediately, but not after a period of time. So you can disrupt protein synthesis, important for consolidating memory, immediately. But after a certain period of time, you can't use that same disruption. So that might make you think, okay, well, there's that initial consolidation, and then once it gets past, the information gets past that stage, it's stored. To disrupt that second phase, that storage phase, you can't just disrupt protein synthesis, you have to disrupt the actual tissue. So a lesion, which is damage to brain tissue, or some kind of disruption to synaptic transmission. So why consolidate and then store? Well, it might lead into this idea again of filtering information, right? And there might be an opportunity there to modify memory and add information that's useful. It could also be a byproduct of evolution. Because both of these processes take time, so they have different stages. So there's no clear answer to why consolidation. Okay, and then retrieving those memories, that's accessing that stored information. So when do we retrieve information? There's recognition, and then there's recall. So you might just recognize something kind of passively, and that retrieves a memory. For example, identifying something familiar to you. And then recall is generating the information in memory. This is more effortful. So recognition, kind of more automatic, doesn't take as much effort. Recall is trying to think and remember a piece of information. Takes more effort. What improves retrieval? Context. Context is incredibly important to improve retrieval. So when you study, don't study high or drunk, unless you plan to come to class and do your test that way. I would advise against that. But it's true. The context of even just having a drug in your system changes retrieval, changes recall. So be of sound mind when you're studying, so that you can be in the same physiological context. Okay, here's an example though, with a hamster. Right. Okay, so this hamster is being shocked. It's a very mild shock. Don't worry about it too much. Sorry. But basically, these hamsters were shocked. There are two different compartments. There's a shocking compartment, right? And then there's a safe compartment. And there were different conditions of when the hamster was shocked. Either in the night or in the day. And basically, they would have training where they either shock them at night or in the day. Okay? Night or day, shock. And then during testing, this too, they are allowed to go through either compartment. So you see what they do. Where do they spend the most time? And the training and testing either happens again at day or night, in different combinations. So the important thing here is that the hamsters are actually noticing the context of the time of day. So if you look at the night-night condition, that means they're being trained and tested at night. So during training, they're shocked at night, and during testing, you want to see what compartment they're in at night. And you can tell they spend way more time in the same compartment because they're like, oh, it's nighttime, I don't want to get shocked, I'm going to the safe compartment. But if you look at the night-day or day-night condition, they don't really care what compartment they're in. Because they're like, it's not the right time of day. I can go wherever I want. But then again, you see that same context with day-day, night-night. They want to avoid the shocking chamber. So they created a memory, right? They remember this compartment is the bad place at a certain time of day. Not going there, going to the safe place. So that's context, that's time of day. They're remembering the time of day that they were being shocked. Poor hamsters. Couldn't you have done this another way? But retrieval isn't perfect, right? Memories fail all the time. We know this. Memories are reconstructions of the past, but there are a lot of things that can influence our memories. Things like the emotional state that you're in when you're forming a memory. One of the classic examples in humans, anyway, is if participants here the car crashed into the other car compared to the car hit the other car. The car crashed, they'll always think that the car was moving faster. Right, so memory's not perfect. And the same thing is true in non-human animals as well. So forgetting. Forgetting is actually very important part of memory. And there are two different terms that are kind of important to know. So this is retroactive interference and proactive interference. So retroactive interference is when acquired information works backwards to disrupt previously learned information. And proactive interference is when previously acquired information disrupts the formation of subsequent learning and memory. All right, so that's where we're gonna end. So we just made it to 3:20, so ended like an hour early, very nice.